Hi and welcome back! The aim of this lecture is to focus on the laser cutting machine as a particular case of subtractive technology. This is the most flexible of the subtractive technologies. First of all, let's go over the definition. Laser cutting is a non-contact process which utilizes a laser to cut materials, resulting in high-quality, dimensionally accurate cuts. The process works by directing the laser beam through a nozzle onto the workpiece. A combination of heat and pressure creates the cutting action. How does laser cutting work? Explained simply. Laser cutting is a thermal separation method in which many different materials can be cut. This is how quickly you get from the graphics to the finished workpiece. First of all, you need to have an idea, which means defining the geometry and the material. The graphic is created in a vector program such as Adobe Illustrator or Inkscape, which is an open-source vector software. After the design phase, the data are simply sent to the laser cutter and all the cutting parameters are defined. You have to insert the material, for example plywood, on the top of the processing table and then press the Start button. The material does not have to be clamped and also does not have to be modified at the device. However, it's important that the material is completely flat and straightened out. The finished workpiece can be removed as soon as the laser process is completed, without reworking. Then the laser heads, traces the vector image and cuts the design out. The laser can cut a wide array of materials such as acrylic, wood, laminates, film, paper and, of course, textiles, both natural and synthetic. Industrial laser cutters equipped with a gas-assisted power supply system can also cut metals. However, it will be difficult for you to have access to this type of machines. Here you can see a piece obtained with the subtractive technology. You can use laser cutting to make through cuts, as you can see at the top of the sample, or to make non-passing cuts, as shown at the bottom left, or even to make engraving as visible in the results at the bottom right. The results are different because the operating systems are different. In fact, the left side of the sample works with vectors, the right side with raster images. In the first case, when you use vectors, the laser source moved from A to B following the path. In the second case, when working with raster images to create the same spiral, the laser moves along horizontal lines. The source turns on only when it is above the spiral, but you do understand that this takes longer. How does the laser figure out what to do? To get the two different results, you need to set the file differently, and after that, make several tests. In this example, the black line corresponds to engraving, whose features are different thicknesses, different filling percentages, possible font reproduction, and resolution as DPI, because it uses horizontal processing. The red line, on the other hand, indicates the cutting, whose features are specific thicknesses, recognition of full color only, font reproduction only in outline mode, and working with vectors. Here you can see the final result. Now, after this technical premise, let's explore what can be achieved with this technology. For example, you can create objects cutting slices of material. You can create accessories where cutting and engraving processes give flexibility or three-dimensionality to the flat material. Or you can also create garments and use laser cutting to make voids and decoration. Apparently, this is not big news at all, because laser cutting is already in use in the fashion world, especially in leather processing. But the important thing is that this technology allows great flexibility combined with fast production, so it can enable the realization of countless design solutions. Generally, laser cutting can be used for basic or advanced applications. There are different applications of laser cutting in fashion, some that do not present particular complexities, while others that require a greater awareness of how a two-dimensional geometry can acquire three-dimensionality through cuts and insertions. In the first instance, patterns and textures can be created with laser cutting. This technology is also particularly suitable for reproducing auxetic structures, which can act not only as patterns, but also to break down the two-dimensionality. Secondly, laser cutting can be used to create inserts and connection systems, such as slots or edges for assembling multiple parts without a sewing machine. A further application of this subtractive technology is the creation of paper patterns. Laser cutting can be used to cut the paper pattern directly onto fabric, paving the way for a zero-waste design approach. With the heat of the laser, in fact, the edges of fabrics based on synthetic fibers will be automatically welded, and the pieces will be usable without creating hems. In addition, with this machine you can also create customized punch cards to be used to make custom nightwear. The latest application of laser cutting present in this lecture is called modular fashion. Modular fashion is an approach to the production of accessories and garments using vector graphic design of bidimensional laser cut modules. They are then interlocked to create complex 3D seamless geometries. In this picture you can see some examples of modules made with the logic of modular fashion. So, during this lecture we have explored the possibility offered by this particular technology. And in conclusion, I want to show you this video that displays the laser cutting process in real time during the production of one of the modules in the previous image. As you can see, the engraving operation takes more time and consequently has a higher production cost, because the machine follows a raster logic. Meanwhile, when the machine performs the vector cutting operation, it is evident that its efficiency increases. However, some thicker fabrics may require more steps to achieve a precise cut.